at what every level for each, for multiplication, equal groups, division, measurement, imperative, extending multiplication, rate multiplicative comparison, multiplicative connections, and multiplying multiples of 10. We're going to go through each of those levels, so you're going to actually see students, what they look like at each level. And also, what we'll do is after we see what students are at each level, we'll go through the the leveled activities guide and go through the different activities that you can do too. So remember, you get a ton of resources with this, and these are all the things that you can do with the resources that you received. So what we're going to do now is we're going to take a look at the levels, okay? Because when we get into the framework, there's going to be a level A, B, C, and D. You need to understand that for every level, there's actually a higher side of a level and a lower part of the level. And so we're going to go through what that is. But if you take a look at sort of how it evolves, it starts off with there's counting, and level A represents some type of counting, right? Level B is additive composition and counts many to one, also known as repeated addition and skip counting. Remember, B, there's a lower part, which would be additive composition. There's a higher part, counts many to one. We're going to go level D is flexible multiplicative reasoning, which is, when students just are, using math facts connected to multiplicative situations. And then level C means that they rotate. They may do some problems at level D. They may drop back and use additive composition or counts many to one. Okay. And so now we're going to kind of go through. And when you take a look at the assessment, this is what one of the scoring looks like in flexible multiplicative thinking, is flexible multiplicative reasoning. And then it says skip counts and repeated addition. Just remember, additive composition is the same thing as repeated addition, and skip counting is counts many to one. The reason why this is easier for teachers to understand, this is the research that was used these terms: additive composition, counts many to one, rhythmic counting, stress counting, and so on. So someone didn't have to have, a math PhD to give this. We said, okay, skip counting, repeated addition, stress counting, counting by ones. So that's just why it looks different, but it means the same thing. So take a look at level A again. Level A, you'll see what stress counting looks like. It represents some type of counting, right? Level B means they're using repeated addition, or they're using skip counting, or a mix of those skip count and additive composition. Level D means they're tying math facts to what they're working on, and they're able to solve it quickly. And then level C means they kind of go back and forth between level B and level D. You remember when you give the assessment, this is what the scoring sheet will look like. And in about 45 minutes, I'll say, we'll be giving the assessment, and then you'll have a chance to actually see what the assessment looks like. And this is an example of what stress counting looks like.
Now they're arranged in threes, aren't they? Could you show me how you count those counters? You can move them if you'd like to.
3, 6.
She's counting by ones, but emphasizing the multiple.
9, 12, 50.
Thank you.
Okay, so we're going to go through now. We're going to go through the multiplication equal group part. We'll be focusing right here. Remember, today we'll go through each one of these, and we'll get to see what students look like, what these, what the questions look like, and this will help us understand what the different levels are. So right now we're going to go through what level A is. And level A, if you remember from a few slides ago, level A represents some type of counting by ones. So it says student counts 1 to 1 when presented with an equal groups problem. To progress, they need to begin to identify the number of groups, how many are in each group, and without being prompted. If there were 4 tables in a room that looked like this, how many people would there be? So there's 4 tables that have that number of people in a room.
So just add like 3, act like there's 3 more tables, or 4 more?
Well, so there's 4 tables that look exactly like that. So it'd be 4 total tables like that. And remember, she can skip count by 5s, because we tested her earlier and she proved she could skip count by 5s, which many kids could. But she has a perfect situation to apply that, and she's not.
I counted all the people, and then I was thinking 4 more tables, and then I counted the people again, and then I acted like there was more people, and I started counting.
Okay, how did you count?
I counted like just once.
Okay. How many dots are there in the array?
In their array?
How many dots are there in this array right here?
Money?
How'd you get that?
I just counted.
Okay. And what'd you count by?
I counted by ones.
Okay. And so for characteristics of students at level A, grouping does not make sense. They do not realize that skip counting will give them the same total as counting by ones, even if they know the skip counting pattern. Again, most kids can skip count by 2s, 5s, and 10s. And even when they were given ones that had 2s, 5s, or 10s, they still counted by ones. Does not see the count as a permanent indicator of the quantity of the collection. They do not trust the count. Even if they know that they're going to have, like, there's 4 people at the table, and then there's another 4 and another 4, they don't trust the count. So they go back to the count that they do trust. They trust the count by 1. May be able to make groups to represent a multiplicative situation. However, they count from the beginning in order to find out how many. So for example, if a student who's thinking at level A was given a story problem, this is what it would look like. So there are 4 buckets with 5 apples in each bucket. How many apples are there altogether? Write an equation. So they go ahead, all right, 1 group, 2 groups, 3 groups, 4 groups, there's my buckets. Then they're gonna go ahead and put those in there, and then they're gonna go ahead and go, okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're going to solve it counting by ones. Now, as a teacher may go through and look at this and say, wow, they really showed they understand multiplication. But all they did was just make a giant set and just count from 1. So even though it may have shown that, it may look like they understand multiplication, they're actually using a really low-level strategy of counting by ones. And then we look at this and say, well, they understand multiplication. They know how to make the groups, but they're not doing any type of multiplicative thinking to solve this. And then at the end, we may say, okay, go ahead and write an equation. And then they're almost like programmed. Like, oh yeah, when I'm all done, I'm going to write an equation, but think they didn't even use this equation at all. So if you take a look right here, and what it says is even though there's a clear structure to this situation, she's viewing it like this, okay? A grouping of unconnected and unrelated ones. The only type of count she trusts is the count by one. So even though, I'm not saying this is exactly how she's seeing it, but she's treating it just like this, okay? A collection of unconnected ones with no groups, okay? And for this one right here, it says, data from earlier showed she can orally skip count by 5s. However, when given an opportunity to apply skip counting to be more efficient in the multiplicative situation, she chose to count by 1s. So again, she can count by 5s, but she's not using it. So she's being, why is she not using it? Because she's not making a multiplicative connection to that situation. And again, even for this one right here, her data showed she can't skip count by 6, but a more efficient, higher level strategy just be for her to add these 6, 7, 8, 9, 10, 11, 12, 13, 14, to go ahead and that, but she didn't even try to use repeated addition. She just counted everything by 1s. So instructionally, this is what you would do. So this is what the leveled activities guide looks like, or this is just a clip of it for levels A. And remember, level A means that they weren't even able to do it. Level A means they're counting by 1s. So this is the types of things that you would do with them, okay? So the first one is you would show them equal groups models and array models. And remember, how many groups are there? How many in each group? Write a repeated addition problem. Can you skip count to find the total? Your goals for level A or level AA are really easy. The first goal is you want them to start to identify groups and how many are in each group. Next, you want them to connect it to addition. And the third one is create a reason for skip counting, okay? And they may not be able to know how to skip count by all these, but you want them to learn, wow, look, if you can skip count, this is much more efficient than if you are just counting everything by 1s. So for the array, too, I want to show you this. For the array, when kids are working with arrays, it's just like reading. You read from left to right, and then you sweep back with your eyes. So this would be 1 group, 2 groups, 3 groups, 4 groups. So left to right, sweep with your 1 group, 2 groups, 3 groups. And again, have them work that way. Okay. Another one is the part whole model. And this is a good model, very important when developing division, but you let them, they can see the answer, which is 18. They can see the groups, and they can see the number in each group. So again, how many groups are there? There's 3 groups. How many in each group? 6. Write a repeated addition problem, 6 plus 6 plus 6. Can you skip count? They're not going to be able, most kids who are struggling aren't going to be able to skip count by 6. But you can say, if you were going to skip count, think how much faster it would be to go 6, 12, 18, and try to count your way through. And finally, again, equal group or pictorial cards or number cards, same thing. Your whole goal for level A is how many groups are there, how many in each group, write a repeated addition problem, can you skip count to find the total. And these last 2 things, these are not included in your materials, but if you have a deck of cards or better 2 decks of cards, which will give you up to 8 of each card, you can do the same thing. Build problems, how many groups, how many in each group, repeated addition, skip counting. That is your goal. Our goal is for them to identify groups, a number in each group, connect it to addition, and connect it to skip counting. And that is your level AA and level A instruction. And think about this. This seems so far away from those kids, but remember, these are 4th and 5th graders that we're looking at right now. And when you're in 4th grade, you're going to be asked to do a problem like this. So what making sure they understand the meaning does is, a lot of times we'll just say, okay, 5 times 1/4, just multiply across and you'll get 5/4. But remember, 5 groups of 1/4, this is exactly what it would look like. 1/4, 1/4, 1/4, 1/4, 1/4. And it gives them some meaning, okay? So that's how you get 5/4, or you could say 1 1/4. But again, making sure they have that foundation of this is what equal groups is. All right. In 4th grade, and I'm not sure if this is 4th grade or 5th grade, where they have to multiply a fraction times a fraction. So we're like, think about this. 1/2 times 1/4 is 1/8, right? Well, again, half of a group of 1/4. So there's 1/4, and half of a group would look like that, and that would be what 1/8 looks like. So again, adding meaning, because sometimes I've heard teachers say, well, multiplying and dividing fractions is really easy, which the process, the procedure is, but teaching the understanding of it is very, very difficult. And this is what it would look like. So when you have a student who is at level A, right here, and this is level A, and then this is what the multiplication equal groups e-lesson or lesson plan looks like. And remember, this can be done over in your classroom. You could share it on a laptop. You could do it on a smart board. You could do it on a Promethean board. It's this is your mini lesson that you're working on. So if you take a look, level A and level AA, these are the students you're working with. And right here it has concrete models level A, okay? And if you take a look down here, what it says is the strategy for level A is counts by 1s to solve problems with equal groups. And it'll tell you, begin to understand how to manage groups, how many groups and how many are in each group, connect to addition and skip counting. So if you take a look with the lessons the mini lessons that you'll be doing with them, there's a bunch of these. We'll just go over a couple. It says how many groups are there. The prompts are at the bottom for you. So you would go and say how many groups are there, how many in each group. Oh, there's 5 groups with 2 in each group. The next one says how can we show this problem as an addition problem? 2 plus 2 plus 2 plus 2 plus 2, and the skip counting. Again, the next one, how many groups are there? How many in each group? We have 5 groups with 5 in each groups. How can we show this problem as an addition problem? 5 plus 5 plus 5 plus 5, or by skip counting, 5, 10, 15, 20. And then when you're done with that, again, this is when you're working with your students. You already saw what the independent part looks like. There's the multiplicative thinking book. And what you do is you go ahead and there's the answer sheet for level A and level AA. Remember, our goal is what? All about groups, repeated addition, skip counting. So they're going to go through, and this would be their groups. How many groups are there? There's 3 groups here with 3 in each group, 3 plus 3 plus 3. And again, for skip counting, we have skip count by 3s, 3, 6, 9. And this is what, using the lessons for level A would look like. So now we're going to go on to level B. And what level B is, it says student uses the additive composition strategy when calculating the total for equal group problems. To progress, they need to learn how to use the multiplier multiplicative as an operation, or the groups and the number in each group. And so we're going to take a look at what level B looks like.
36.
Okay, how did you get that?
I did 6 plus 6 plus 6 plus 6 plus 6 plus 6.
So just kept adding 6 and adding 6 and adding 6. Okay. How many cans of soda are there?
36.
Okay, how'd you figure that out?
I will. 6, 12, 18, 24, 30, 36. Let's try.
Okay. How many squares are there total in that array?
24.
And how'd you get that answer?
I saw 4 before this row, then I saw kind of 4, 8, 12, 16.
Okay. So you counted up by 4 stuff?
Yes.
All right. Okay, remember for level B, there's a lower side, which is sort of the repeated addition or additive composition. Then there's the higher side, which is the skip counting. Okay, in characteristics, understands that the count is a permanent indicator of the quantity. They can take advantage of the groups to count more efficiently. So once they figure out how many are in one group, they just keep going all the way through, and they trust the count. They know that there's going to be 4 and 4 and 4 and 4 and so on. Once the group is recognized, they do not need to go back and count the other groups, right? They understand the concept of the count. The quantity can be arranged in different ways, and it will not change. But the focus is on this, and this is sort of, remember, level B is, think we're level B about working on equal groups, but we're making this focus right here because this actually has to do with division. But think how far away we are from division, because if this is in place, it's going to affect their division. It says the focus is on the multiplicative, or how many in each group, but not the multiplier, the number of groups. So they view the multiplier as the number of when to stop counting. The multiplier is not coordinated with the multiplicative before the count. A little confusing, but here's what that means. When they're doing repeated addition or when they're doing skip counting, what he's doing is going, okay, 4, 8, 12, 16, 20, 24. He has not accounted for that he just counted 4 6 times. If there would have been 7 4s or 8 4s or 9 4s, he just would have kept counting. But in order to really understand division and be a multiplicative thinker, you have to be able to take the multiplier and the multiplicative, or the number of groups, and the groups and the number in each group, and coordinate them before you actually start solving your problem. So instructionally, what we'll be focusing on is, well, them creating equations. So again, when they are, this is what a student who is functioning at level B, if they were given the story problem, 4 buckets with 5 in each bucket, how many apples would there be? They'd either do repeated addition or skip count by 5, 10, 15, 20. And then at the end, they'd know they'd have to write an equation, so they'd go ahead and write 4 times 5 equals 20, but they wouldn't have used that equation to actually get the answer. It would have been the last thing that they created, not the first thing. So when looking at level B, there's 2 goals, right? Just like level A, it's all about making sure that they understand there's groups and number in each group, repeated addition. Level B is all about this, create a multiplication equation. You need to write an equation. Level A, we didn't worry about writing multiplication equations. Level B, it's all about that. And the second part of level B is teaching them about the commutative property. So if you take a look right here, what we have is, we have an array, and a screened array too. And the reason why it's screened is because we want them to focus in on not just the number in each group, but the number of groups. So how many groups are there? How many in each group? Use the multiplier and multiplicative to create a multiplication equation. What is the total, right? Remember, number in each group, or how many groups too. You don't have to use the term multiplier, multiplicative. And again, right here, we have a 3 and then a bunch of 3s turned over. Okay, we have 3 in each group, but how many groups are there? So you want them to focus on not just how many in each group, but how many groups are there. And again, working on the commutative property. So again, right here, screened array. And remember, with arrays, you can go ahead and rotate it. So 5 times 6 and 6 times 5. And again, every question has to do with them producing a multiplication equation, right? They work with the part whole model at level A. Now we've actually covered up the answer. They have to focus in on the groups, the number in each group, and then give us the total and write an equation. And again, when working on the commutative property, go ahead and with cards, you can go ahead and give them 3 4s, which would be 3 groups of 4, or 4 3s. And what's great about the commutative property too is when you use an array, all you have to do is rotate it. This is really easy for them to understand. It's hard for kids to understand that this right here is also the commutative property, and that 3 and 4 and 4 3 are going to equal the same thing. So when you start teaching about the commutative property, use the arrays first and rotate them, and then go on and start working with equal groups. But remember, the entire focus is creating equations. So this is what, again, using the materials or the e-lesson and what it would look like. So you have level B, which is additive composition, or they're using skip counting. So if you take a look here, there's 2 different parts of this that have to do with level B. One is the partially screened models, and the other is what we'd be working on is the commutative property, okay? So we'd go ahead and take a look right down here, and it tells us about level B, and create equations using both the multiplier groups and the multiplicative number in each group. And that's exactly what we're going to do. So take a look. Remember, the question prompts are down here. And it's really neat how this works. How many groups are there? Well, it's screened in a way that we can't see all the groups. So we don't know how many groups there are altogether because we can't see under the screen. So all we can see is one group, right? How many in each group? Well, we know there's 5. So what's missing? Well, we don't know how many groups there are, but we do know that there's 5 in each group. Then the next slide, what does it do? It shifts over. So, okay, now I have to start paying attention not just to how many are in the group, but the groups themselves, and go ahead and create an equation, okay? Now for the next one, again, they can't see how many groups there are, or they can't see how many groups, they just can see how many in each group. Then we'll go ahead and say, okay, now we're going to shift it over, and what this does, it forces them with their eyes to account for both the groups and the number in each group. And then the next thing would be, when you're working on the commutative property, this is a different set of lessons, you click on it, and it just says write an equation for each picture. What do you notice? And that's just an array that's been rotated 2 times 7 and 7 times 2. And that is working now working in the multiplicative thinking book. Again, level B has to do with groups, number in each group, and writing a multiplication equation. So when they would go through and work in this book again, it's all these screened arrays. And remember, when they're working the multiplicative thinking book, this is what they're doing with you. There's only 6 problems. You're watching them work on this very quick, and so you can sort of problem solve and troubleshoot any problems that they may have. And again, for the commutative property, it says no answer sheet needed. You don't need an answer sheet for that. You would just print this up. And some of the books, some of the things in the multiplicative thinking book, you need the answer sheet. Other things you don't. It tells you if you do or not. Okay, what's interesting about students who are in level C, and level C is a good level to be at, because it shows that they're able to do thinking at level D, they're just not consistent with it. So they sort of float in between level D and level B with what they do. And so student alternates between additive composition and flexible reasoning. To progress, the student may need to practice facts. They may also need instruction that focuses on identifying the structure that exists within each problem. So we'll talk in another slide or two about the instructional decisions you have to make with level C, because it's not always as obvious as level B, level A or B or C or so on, okay? Okay. All of the cards are 4s. What is the total?
16.
How'd you get that?
Because you said there was 4 in each, so 4 and 12, 16.
Okay, so he skip counted. If there were 4 tables in a room that looked exactly like that, how many people would there be? So there's 4 tables that look just like that.
20.
And how'd you get that?
Because there's 5 people at the table, and if you times it by 4, it's 20.
Okay. The rectangle is covering up some of the dots in the array. How many dots are there total?
15.
And how'd you get that?
Because you said that there was, if you count there's 3 in each row, and there's 1, 2, 3, 4, 5, and if you times by 3, it's 15.
Okay. So characteristics, it says situationally understands the multiplier and multiplicative are coordinated prior to the count in order to produce a multiplication operation. Situationally understands multiplicative situations involve 3 aspects: groups of equal size, multiplicative, number of groups multiplier, and the total of product. May have a basic level of mastery of facts. Most children at this level need mastery of facts to move to level D. So the only difference, I don't want to say the only difference, but level C students often have a pretty high level of understanding. They just don't have complete command of their facts. So again, a level C student, when they're doing the same story problem, there are 4 buckets with 5 in each bucket. They may either go, 5, 10, 15, 20, or they may just say, oh, that's 4 times 5 and that's 20. And what usually determines their strategy is how comfortable they are with a particular math fact. If they know it, they'll use it, and if they don't know it, then they'll revert back. So when doing instruction at level C now, if we take a look, level C is a really interesting level because there's going to be 2 reasons why a child is a level C, right? And if you take a look, there's nothing in this lesson plan that is specifically for level C. There's things for level, there's things for level A and level B and C, and everything is shared, but you're going to see there's nothing specific that says just level C. So what you have to decide is when you're working with a student, okay, why are they a level C? All right, and there's going to be 2 reasons, right? One is, do they know their math facts, but they just don't consistently use them? So if a child knows their math facts and they're not consistently using them, they need more work on the structure, right? And identifying it and connecting it to it. Is the weakness in facts holding them back? When they know the fact, do they use it? And also, when you give the assessment, you're going to have a score for their multiplication division facts, which will help you also determine this. But if a child knows their facts and they're not using it, you would do more structural teaching. And partially screened models, that level B, level C that we just saw when we were working with level B, would be the type of instruction that they need. If they are, if their weakness is facts and the facts is holding them back, but they have the thinking, you would do 2 things. One, you could go ahead and start to instruct them at that level CD with the partially screened models, which has to do with 1 more and 1 less. Because remember, a lot of students who are level C are very high thinkers. They just don't have command of their facts. And also at level C, what you could do is this is when you could focus in on math facts. So if you think about, earlier today we were talking about, when is it kind of appropriate to just have students focus on math facts? Level C is a perfect level where you could actually say, all right, we're going to have you work on your math facts. Now, a student who's on level A, math facts is just too far of a bridge for them. Not that they can't work on it, but it's not going to solve, what their problems are, what they're missing. Again, level B, the math facts isn't going to solve because they have structural issues, structural understanding issues, not just math fact issues. So if a child's a level C and the weakness is facts, you can still give them higher level instruction, level D instruction for the structure, and also work on the math facts. Okay, level D now, and level D is exactly where I want our students to be. It's where all your standards are written. So if you look at 3rd and 4th grade standards and match it to the framework, all those standards are requiring them to be thinking at level D. And level D says a student consistently and efficiently uses the multiplier and multiplicative simultaneously as an operation. To progress, the student will need to understand the inverse relationship between multiplication and division.
Now, how many cans of soda are there total?
36.
How did you figure that answer out?
I counted one group of the cans and they had 6, and then I just did 6 times 6.
Okay. How many dots are there in this array?
20.
Now, how'd you figure that out?
We have 5 times 4.
Okay. How many beads are there?
13.
How'd you figure that one out?
I did 3 times 4 plus 1.
If there were 4 tables in a room that looked like this, how many people would there be?
Oh, I was in pictures. Okay. 20.
How'd you figure that out?
5 times 4.
Okay.
So characteristics, it says understands that multiplier and multiplicative are coordinated prior to the count, right? They'll create an equation. Understands multiplicative situations of all 3 aspects, okay? They're able to use multiplier, multiplicative, and product, and can use the relationship of the product and groups to solve from one of the things is missing. So we'll take a look at what level D instruction looks like. Can create a new equation with a sudden change to the structure, and mastery or close to mastery of facts. So again, for level D, this is how a student would solve it. They'd look at this problem and just use a fact. And so when looking at the leveled activities guide too, the first part of this is making sure that they understand. So they're going to be given, instructional things, and there's 2 parts to it. Write a multiplication for this picture. They're not going to have any problems with this. Write a missing factor for this picture. So they would go ahead and you say, okay, you need to go ahead and say if it's 4 times 5, leave one of those out. So 4 times something equals 20, or 5 times something equals 20. We're going to get into more detail of missing factors when we work on the division connection. But for this part, we're going to say just pick one of those numbers just so they know you can have a missing factor equation. If one more group is added, what would the equation be? And again, kids who are level D, they usually get through this instruction of just extending their understanding. It's really easy. And think, an equation for a picture, they'll have no problems. Missing factor, not a big deal. And then if one more group is added, then again, that's really easy for them. But level D, once they can do those things, this is huge. And it's called the division connection or the missing factor. And what this has to do with, they're not going to start doing division problems. They're going to start actually giving multiplicative situations with missing information, and they're going to have to write not a division equation, but a multiplication equation matching the scenario with missing factors. And this will be how we work on the bridge to division. So here's what it would look like. So level D, if you take a look, where all level D is, and remember, some level C kids will also receive this instruction. If the only issue is a child just doesn't have their facts learned, they can go ahead and still continue to have this too. So if you take a look, partially screened models, this would be 1 more or 1 less, okay? And this is where level D, and that just tells you what you want to focus in on. And then algebraic models would be D+, once they can do the partially screened 1 more or 1 less, and you'll see what that looks like. Then you go to the algebraic models, which is, and if you take a look right here where it says the division connection, this is a really important developmental thing that you have to go through. So if you take a look here again, this would be in the E lesson, right? And it says, write a multiplication, what multiplication equation can represent this picture? And they're going to go ahead and say, 3 times 6. If there was 1 more group, what would the equation be? Okay, and again, 1 more group's put in there, then they have to go ahead and do 4 times 6 is 24. Again, this is not very difficult for them, but it's something you need to make sure is in place. Once you go through and they can do, add 1 more group or 1 less group, then what you can do is you can go ahead and go to the algebraic models, the division connection. This is, remember, it says D+. Now, D+ is not a tested level. It just means you've gone as far as you can with level D, and now they're ready for this division connection. So take a look at what this says. It says 18 jars, 3 in each group. How many groups? All right. Also, this is a measurement division type problem, but here's what we're going to say. Look at the prompts. How many groups? How many in each group? How many total? And so again, we don't know how many groups there are, but we know there's 3 in each group. We know there's 18 jars. So write an equation with a missing factor. Remember, we don't know how many groups, so it's something groups of 3. And then the prompt says, what number times 3 equals 18? It'd be 6 times 3 equals 18. Okay. And again, 18 jars put into 6 groups. Now this is a partitive division problem. But again, we're not solving it in the division way. What we're doing is we're solving it with a multiplication equation with a missing factor. So we know there's 6 groups. We don't know how many each group. So again, the equation is going to look different. Now it's 6 times because we know how many groups, but not how many in each group. And equals 18. Again, 6 times what equals 18 equals 3. So we're making a division connection. We didn't say the word division. We're still solving it through missing factors. And again, the same one, a different model, 24 partition 8 to a group. How many? Okay, and the last part that I want to go over is just this last part right here. We've gone over everything, but we have not gone over the multiplication 2 digits by 1 digit and multiplication 2 digits by 2 digits. So just to be clear, before you work on this, you wouldn't start working on this if your students get to level D right here. They need to be at level D at everything, especially for multiples of 10. So don't think, okay, I've gone through everything. They've done the algebraic models, and now we're going to do this. This is sort of, it says D+, where it means that they have to have everything here. So this is what the framework should look like when you get to this. And here's just what some of it looks like too. So remember, level D across the board almost in everything. And then, again, if you have a 3rd grader and they're ready for this, go ahead and teach it to them. There's nothing wrong with going above and beyond for students who are ready for it too. So, and for 2 digit or 1 digit, what it does, it teaches them different strategies, right? So the office buildings windows were arranged in a 7 by 14 array. How many windows are there? And then go ahead taking them through and showing them how that works too. So not just teaching them the process, the procedure, but how to apply it. And then there's other methods too. I got place value sections, expand, and notation. And remember, for all of this, is the idea is when you start working on this, this is your fourth grade stuff, your fifth grade stuff. They need to be at a level D at everything before you can start working on this right here. So remember, this is sort of your goal to get here, but everything has to be up to par for that. So now we're going to go through the division. Remember, we learned earlier about